Okay, so this says let P of S be this function S over, this is a little small, S over S plus 1, all subtracting 1 from that. Find the following. P of 1/6. So I'm just going to rewrite this. This is like a practice in manipulating fractions. So the S on top is going to become 1/6 all over 1/6 plus 1 quantity minus 1. Okay, ignore this for right now. Let's just worry about simplifying this. So I'm going to start here with this bottom fraction here. I'm just going to circle this and simplify this thing over here. 1/6 plus 1. Well, I need to get a common denominator so I can multiply 1 by 6 over 6. So this is going to be 1/6 plus 6/6, which gives me 7/6. Right, your calculator can do a lot of this, but you don't want it to do more than really is necessary. Let's see here. So if you do 1/6, 1 divided by 6 plus 1, then you're going to hit math, and then hit the first option, enter fraction, 7/6. That gives us that. So that's this thing right here. So I'm left with 1/6 over 7/6. Okay, I'm dividing a fraction by a fraction. When I divide a fraction by a fraction, that's the same thing as multiplying by the reciprocal. So I'm going to take this second guy and multiply by the reciprocal. So I have 1/6 times 6 over 7. When I multiply those, I get 6 over 42, which reduces to 1 over 7. Your calculator will reduce as well. If I do 6 divided by 42, and then that math fraction button, it'll reduce to 1/7. So this whole thing here is going to be 1/7 minus 1. Well, 1/7 minus 1, you can do that. You can get this to be 7 over 7, or you can just subtract and you'll end up getting negative 6/7. 1 divided by 7 minus 1. Math, enter, enter. Negative 6 over 7. A little trickier here, just watch the signs, but it's going to work relatively the same way. Okay, this one here. It looks like everything you did was good from the start. So this here, we're just going to replace each x with an a plus 2. So this is 8 times a plus 2 squared minus 8 times a plus 2 plus 14. I'm going to start by foiling that thing. So I have 8 times a squared plus 4a plus 4. I just wrote that twice and then foiled it out. Minus 8a minus 16 plus 14. Distribute the 8. We have 8a squared plus 32a plus 32 minus 8a minus 16 plus 14. So then you can just combine like terms. I only have one 8a squared term. A terms, 32 minus 8 is 24a. 32 minus 16 is 16 plus 14 is 30. So that's going to be my answer for this guy. And then the last one, it's just taking f of a, which you have right here, and adding to it whatever f of 2 is. If you plug in 2 into the original, you'll end up getting 30 out. So you're just going to take this thing and add 30 to it. This is 8a squared minus 8a. 30 and 14 are the only like terms, so that'll be 44. Okay. Moving right along, it says the domain over the real numbers of the function square root of 4x plus 17 is in the form of either negative infinity up to a number or from a number to positive infinity. So we need to figure out what's the boundary here. Not necessarily negative 4. The thing to know about square roots is that the expression inside the square root has to be greater than or equal to 0. Because you can take the square root of 0, you can take the square root of a positive number, but you can't take the square root of a negative number. This is no-go. So whatever's inside there has to be greater than or equal to 0. So whatever x is, 4x plus 17 has to be greater than or equal to 0. That's the rule. So it's just a matter of solving this for x. If I subtract 17 from both sides, I got 4x is greater than or equal to negative 17. Divide by 4. Divide by 4. So you get x has to be greater than or equal to negative 17 over 4, or x has to be greater than or equal to negative 4.7. No, 4.25, sorry. So you just need to add this 0.25. So it's going to be x is greater than or equal to some negative number. So it's going to have this form. It can be negative 4.25 up to infinity. So that's why this is the correct answer. If it was less than or equal to, this would be the yes and this would be the no. Okay, which value of the t is not in the domain? So like with square roots can't be negative, but denominators cannot equal 0. That's the big no-no. So if you're trying to figure out what numbers are not in the domain, it's the values of t that make the denominator to 0. So we can find them by just saying let the denominator equal 0 and see what we get. We get negative 6t. I'm going to add 27 to both sides. Divide by negative 6. I get t equals negative 4.5. Okay. Because if you plug 4.5 in, you're going to get negative 4.5. You're going to get 0 in the denominator, which is a no-go. No good. And the last one's similar, but it's a really weird way they set it up, so I understand the issue. From which of the following formats should be used for the domain of the function? So yeah, this is not a square root. So we're not talking about like an interval or an inequality like this. But the only things we can't have are the values of x that make the bottom 0. Denominators can't be 0. Okay, so let's figure out what values make the denominator 0. So I have x squared minus 2x minus 15 equals 0. Well, this is going to factor. So this is x multiplies the negative 15, adds up to 2. That's negative 5 and positive 3. So when you set those both equal to 0, you get x equals 5 or negative 3. So when x is 5, I get 25 minus 20 plus or minus 15. 25 minus 10 minus 15, which is 0. And when x is negative 3, I get 9 plus 6 minus 15 is 0. So these are both bad numbers. So these are the numbers that are not in my domain. So based on the above choice, we'll fill in this one. X can equal 5, and then it says use a comma, or negative 3. And we will leave these boxes blank. Okay.